Hey, good morning, Monica. Good morning, Priyanka. We'll wait for a couple of minutes. We'll have more participants who are joining. I hope my voice is clear and audible, right? Please raise your hand in case it's clear and audible for you, or you can unmute yourself and confirm it as well. Hey, hi Nandini. We'll wait for a few more minutes, everyone. I hope you're able to see my screen, right? Please do confirm if it's all fine, just to make sure everything fine from my side as well. Cool. Thank you, Nandini. And as we have a few more participants who are joining the session, uh, meanwhile, if you guys can uh, take this opportunity to introduce yourself. Just I would like to know about what experience you have, with level of experience, and what is your interest in terms of databases, so that I would have some better understanding about the participants and their interest as well. You can take your chance to use the chat window, or you can unmute yourself and talk through as well. Yeah. Hi, Cedric. Hi, Ishwar. Yeah. Hi, Krishna. Cool. Thanks a lot, everyone, for joining this session on Oracle SQL and PLSQL. And very good morning, everyone. So, this is the second demo session in the series for the Oracle SQL and PLSQL for batch 318. So, and myself, Venkata, I'll be walking through this course and help you to learn or clarify any doubts or any questions you have it in terms of databases. Feel free to unmute yourself or use the chat window to raise your question, put down your question, so that it's it's not going to be helpful for you, it's going to be helpful for others as well. Okay. So this session we started from yesterday, that is for 17th of June, and this session is going to be like an hour session from 7:30 a.m. to 8:30 a.m. every weekday, and this is total of 30-day course which we would cover about Oracle, but particularly about database management and relational database management, and then we walk into the SQL. We start with the basics of SQL, and then the concepts of creating the tables, inserting the data, or creating the data, you can say it as, or querying the data and then deleting or modifying the data as well. After that, we will jump on to the PLSQL session where we would discuss about the concept of PLSQL, the block structure of the database, and how you can, what are the different types of PLSQL components you have it, the purpose of each and every component. And then we jump on to creating those components and making use of those components to execute some of the business logic as part of the execution. We would cover all those concepts in these 30 days of Oracle SQL and PL SQL. So the first three sessions, we would have it as a demo or a free session to attend for everyone. In case you have anyone in your network who is interested, please do share it across with them once again. And the fourth session onwards would be a separate link which would be shared with the paid members who are nothing but the registered members to continue on the course. So once you registered for a particular batch, we don't have the option of shifting it. Probably in case of any valid reasons whatsoever, please do reach out to the support team, the Logic Lab support team. The contact numbers are available uh, over the screen for you, and the session, the WhatsApp community link, I would ping over this chat window as well once again. So please do uh, take a moment to go through the website, see the upcoming courses, and see the ongoing courses whichever you're interested, and register for it, and make use of this opportunity to learn something new which will eventually be helpful for you. And the support team would be available on the working hours from 9 a.m. to 7 p.m. And these are the our website details. We have the social networking details as well. You can simply search on the social networking websites or visit our website directly, where you can uh, see through the different courses which are available, and you can get through all the WhatsApp community links and the payment links and everything part of this website itself directly. I'll, in case you don't have seen that, you can open the website link, the logiclaxtech.com, and you can go through all the upcoming batches. They're currently ongoing, open for registration, and the ongoing batches which are already started with. And all these sessions, the free sessions are recorded. You can go through those free sessions. You will have the link in the WhatsApp community once you join the community as well. Okay. uh, cool. Think that's the intro in terms of what we are going to discuss or about this session and the overview of the plan for the session. Okay. And before we start with Roy, so I would like to take a minute pause here and participant, please take this opportunity to use the chat or unmute yourself and talk through in case you have any questions, clarifications anywhere in the session. And please do use the chat or use this unmute and talk through. Please do mention your expectation and what is that you are expecting in terms of the concepts you want us to cover, and in case you want anything particular concept which you want to stick to, explain or give more examples part of these sessions whatsoever, I'm happy to do that. I can share more real-time use cases on it as well. And anyone, any question, any clarification before we start? Okay, looks like Ishwar, you have any question or you have anything to say for all the participants? You can use the chat window as well. Okay, cool. So we'll start with the session on the Oracle SQL and PLSQL. And don't get confused seeing the slide. What we have says Oracle SQL, and because eventually before we step on to the Oracle PLSQL part, the SQL is the basic building block pretty much into any database. We have it on the RDBMS. And it's not just about RDBMS, be it NoSQL database to the easy understanding or easy querying purpose, right? To have the simple usage. Many platforms have been using the SQL-like structure to communicate with the database and query the data as well, because the uh, commands or syntaxes which we use in SQL are very much close to our day-to-day usage of the English language. So any platform, any technology used, you would have some sort of reference to the SQL. And before we jump on to the Oracle, the second section of the Oracle database management systems, we will just have a recap of what we discussed in the yesterday's session. We discussed about the purpose of database, why a database is needed, what are the advantages of databases, and advantages and benefits, and the core concept of the database, why the digital form of database has been evolved. We came in from the paperback or a book, and we tried to come next to the next generation of the digital system, starting with files, starting with databases, different types of databases like distributed database, hierarchical database, and multiple different NoSQL databases or object-oriented databases. We discussed about these database types and the essence behind having a database management system, the purpose of it. And then I wouldn't say complete exploring of the Oracle database history, considering the time and the session what we are in. We gave it like a very high level of what was the initial Oracle version which started with, what is the current release which started with, what are those some of the features, what's been the concentrating point of the latest versions. And then eventually the next sessions we would jump on to the Oracle SQL as a fundamentals or basics to it. Okay, and we discussed about database. It's in simple, it's information. Yes, any sort of information in any form we have it, be it paper, be it digital, be it cloud, be it hierarchical, whatever sort. This information is nothing but data, and the place where we store all this information, which can easily be accessible, manageable, updatable, where we can retrieve the data or fetch the data. We call it as database. And we covered about databases needs, why it's needed. We covered about types of databases, and we covered about database management systems, why it is needed, what are the primary building blocks of database management system, and what are the different touch points of these database management systems, and different components like how it is stored, where it is stored, how it works, how it is accessed, and how it evolves, or how it makes sure that the integrity of the data is maintained using the workflows or database rules or procedures, what we call as. And then we jumped onto the Oracle databases, starting with 1979, and then the latest release with 23 AI, the cloud version with autonomous database with AI features to handle some of these workers or agents and speedline some of these manual operational jobs which we typically do on a database management. Lot of these things are getting automated to further extent using AI as well. And today we are going to cover about relational database. And before we start with, I'll pause in a minute here and in let me know in case you have any questions or any clarifications, any doubts in the topics what we have just revised once again on the content we covered yesterday, or you have anything to say to all the participants. Please use the chat or use unmute yourself and you can talk through. Hi Cedric. Cedric, you want to say something? I see you raise your hand. In case you have any question, please do let us know. You can chat in over the chat window as well. You can see a chat option available in the Zoom bottom icons. You see a chat icon as well. Okay. Okay. In case no questions, we'll start with the session of relational database. So what exactly is relational database? We discussed about databases today. We discussed about information. We discussed about database management systems. And next we come through the next subsection of database with a relational database. Probably this is one of the old structure of the the start of the database management systems, or start of the way we store the information, the way we understand the information. uh, Everything starts with the relational structure. Now you might see, right? So anything it's a very simple fundamental topic to it. Anything you oh, sorry. Okay. I see the option to talk through. Cedric, I see your hand again. You want to say something?
Yes,
Yes.
do you hear me now?
Yes, yes, I can hear you now. Thank you.
So, could you, I mean, could you please explain a little bit what what is the OLTP and also the data house?
Yes, I
What
will.
they do over there? Because I mean,
E-
basically, I've heard about it, but I don't really,
Definitely,
I don't know what they
definitely.
are doing.
I'll help you on that. Okay. So when I let's take up this a simple example, right, in our day-to-day life. All right. So one, in abbreviation perspective, when I say OLTP, it means online transaction processing, and we have DW or data warehousing, which is like large data. Now, let's talk about a simple example. Now, you go to an ATM to withdraw some amount. Okay. You swipe in your card, enter your PIN details, enter the amount you want to have it. Now, are we the only customer in the bank? No. There are like millions of customers across the world. But this information, whatever you entered, you hardly would spend few seconds, maybe 10 seconds, maybe hardly 15 seconds at an ATM to withdraw the amount. It has to be quick for you. The place or the system which is designed where the data can be accessed quickly and do some sort of action on top of it, which is a transactional item, which means I create an entry or update an entry or a delete entry where I should be able to modify the information in snap of a second. So these systems which are designed in this sort of business to have the data quickly, easily be accessible, we call it as OLTP databases or OLTP systems. Now, the reason why I say the transaction processing should be quick, because when I do a transaction, I'm doing it from my account. I don't do the transaction from someone else's account at a point of time. So it's information which is getting created or updated. It is the minutest form of your data which is available, and it should be accessed. It should be modified quickly. Like probably one record out of million customers what we have might use the transaction in that 10 or 15 seconds. Not all million customers at a time. Now I should identify that record quickly, get the data, identify the balance what he has, make a debit entry or a credit entry, and then update his record. Done. Everything should happen in fraction of seconds for you. And when I say data warehouse, this uh, name itself talks to, right, as a warehouse, which means you have like tons of information, the complete history, logs, audits, everything. Now you need to do the mining, you need to do the analysis on using this complete historical data. It can be some terabytes or more than that. It's terabytes is a very small word to use for a data warehouse. So you would need to do some sort of analysis which would give you the metrics of a particular structure where we identify the trends, where we identify the usage patterns, where we trying to identify the particular pattern across the different complete zone. That's when we use this concept of data warehouse, where we handle not one entry or one record, we handle the data or the metrics involving the complete data what we have. So that's where we call it as data warehouses. I hope it answered your question, Cedric.
Yes, you did. Th- th- Thank you so much.
Thank you. Um, Anyone else, you have any questions or clarifications, please do raise your hand. I'll try to unmute, and or you can use a chat window as well. Okay, we'll jump on to the next topic of relational database, which we are discussing now. Okay, so the term relation, right? So which clearly tells that you have some sort of linking between the data. Maybe like as an example, which I've taken yesterday, father and son, or a mother and son, or father and daughter, or mother and daughter, whatever be it, right? I'm an individual for myself. I have my own identity. I have my own unique record. Similarly, my son or daughter have their own unique record, unique identity. Two entities are not the same. They can exist independently to each other, but at the same time, there is a dependency relation between them, or some sort of relation between them. And when we maintain the data in the structure which is easily streamlined, easily understandable, and easily usable, where we and there is a link between one data to other data, we call it as a relational database. Now, I'll take simple example. We discussed about college yesterday, right? Or a library. Now, we can take it similar example. A student database in a college or a school, you would have multiple people who are present, and each student is independent to each other. And I would have, and again, each student does not go to the same classroom. Like, individual students goes to their individual streams or subjects which they have enrolled in, and they're going to go to the respective classrooms. So if I see the information, right, all the students as one student entry, because the fundamental concept of that entry in my database is student. Are there only one in my college or school? No. I have teachers, or I have staff who are involved in the college as well. So I would, the even though the identity as a person remains the same, but their identity in the school is different from a staff and from a student. The number of information what we capture for student might be different, and the information what we capture for staff might be different. So in order to do that, we need to streamline the information, identify the granular details of what a student would contain and what a staff would consist. In simple terms, if I see, right, if I see from the college or a school perspective, okay, student entry, I would have, let's say, student name, student ID or a student number, and year of admission, and which stream which he has enrolled in, and what is the current class which he is studying. Probably I might have his contact details and the emergency contact details and address details, which is non-duplicatable, and this is going to be like one entry for student. Simple terms. I have a staff or a teacher. I would have name of the teacher, same information, right? You would try to compare it. I would have name, I would have gender, I would have year of admission or the date of join of the teacher. And for example, if I want to consider when the ex-teachers who left the college, I might have add the date of exit or date of resignation sort of thing. I would have add these details as well. Some of these columns might look very similar, but the essence of these columns is different. So all the information in simple, you might, if I give a notebook for you, you will draw a simple table or some columns in your notebook and write all this information for you. The same structure is repeated on a relational database. And for each classes what I have, I would have the class batch schedule. I would have the duration of the class, when the class is going to be taken. I would consider the teacher who is going to teach the class, and I would have the relation of students who have enrolled to the class, because this information is duplicatable. So we maintain relations between them so that we would easily identify whether it is one-on-one mapping or one-to-n mapping or n-to-n mapping. We would, as we step on to furthermore in deep into database, I would explain about this, what is this one-on-one mapping and what was this n-on-one and mapping as well, the relation structure of it. But you understood the what is relational database. I believe in case you have any question, please do raise your hand, please. Okay, I see Cedric. Cedric, you have any question, Cedric? Okay, anyone else you have any questions, clarification? Please do raise your hand. I'll unmute you, and you can talk through, or you can use your chat. No issues at all. Okay. More you talk, more you express, or more you open your questions, more clarity you would have it, and more understanding you eventually would get it. So feel free to raise your hand and ask any question. And next, we talked about, initially we talked about databases, and then we jump on to database management systems. Similarly, we talked about relational databases, the format in which data is stored, structure in which it is stored, and then we move on to relational database management systems, the applications or softwares which are designed to handle this sort of data structure, what we call as relational database management systems, which would help you to perform all the activities which are typically needed to the structure of relational database. So some of the known, you might have heard about these databases already. like Oracle database, which the session which we are in, or MySQL, Postgres, or Microsoft SQL Server, etc. There are multiple, many more. I just named few for understanding, which are commonly heard. And similarly, you would have for NoSQL, you would have it for object-oriented, and there are multiple database management systems which are designed to handle particular format of data. And there are systems which are defined heterogeneous databases, like based on the format of definition, how we are going to define your structure, it can handle the data accordingly. So as systems kept evolving, keeping the understanding the type of uh, um, data structures or data models which are being used. So even these database management systems has been converted from homogeneous, like in just not just one form of database, the multiple forms of database. So it these even these systems are evolving day to day. And what are the features or the basic need of a database, a relational database? Some of these features, these are, I wouldn't say these are features specific to relational database. Some of these features are common across, generic across any sort of database, because they need to support the ACID support, what we call as atomicity. We will go through those details as we step on, because the identity, the integrity of a particular record or data needs to be very consistent. It shouldn't show that, let's say, if I have a bank account, right? I do a transaction in the previous example. Let's say from $1,000, I withdraw, for example, let's say $100. Now the balance should show me $900, technically or logically. After completing my transaction, it shouldn't still be showing 1,000 for me. And it cannot happen like fraction of second, or it cannot happen like for 5 seconds your balance gets updated, sort of thing. Because this information should be clear and consistent. Once I withdraw the amount, the balance on my account shouldn't show 1,000. Be it the same second, be it in the next second, whatsoever. It should show the right amount of 900 or whatever is the amount which is available in my account. Because this transaction, like the complete event, you insert the card, type in the amount, get the amount, take off your card. This complete event is treated as one transaction. This transaction should either be executed completely or should be cancelled completely. It cannot be done partial. No way you go to any ATM and let's say you mention 100 as the withdraw amount, but the amount what you have got is $50. It would never happen, because it violates the ACID properties. Once I mention 100, either it should give me 100 or it should give me 0, or take the entry where you give me 50. In that case, that's fine. In my account, only 50 should be shown as withdrawn amount. It shouldn't show as 100 again. That integrity, like what has happened, should clearly reflect what is there. So that is where we call it as ACID properties or ACID support. When we go deep into this SQL and writing this SQLs handling or modifying the data, we would come how RDBMS handles the mechanism of data locking, which would avoid the double withdrawals, or which would definitely hamper the data integrity. We would come across more deep into how this is performed as we do get on to the hands-on activities as well. But in simple terms, understand ACID means the integrity of your data, the atomicity of your data. Any database you use in your real life, it should not violate the atomicity and integrity in the data. If it happens at any time, which means the trust of the database management system is lost. So that is the main priority or the number one point of any database management. And second is the multi-user access. The reason why we started with converted into digital, like let's say you have a paper, at, at max maybe one person can write on it, or maybe one or two people can read on. That too, it's not the right way of reading, because you cannot get the 90-degree angle or the clear angle for reading. You're going to get a cross angle, even if I take a simple newspaper. But it cannot happen, right? There are few limitations and few uh, thin lines we need to draw how the data is going to be accessed, how the data is going to be read. You can access multiple people can multiple time at a time, multiple directions. That's fine. But when someone needs to modify it, only that person is supposed to modify. No one else is supposed to do the lock or do the duplicacy there. And any user should be able to access at any time. That's the data durability and data accessibility, where you need to have the data always. You need to have the data. You can increase your data, you can decrease your data. It should be self-sufficient, and it could be easily expandable. Your memory should be expandable. You should add in more data, and you can continue using it. And I said consistency, that's the other important point. When you read the data, right? So it should not be like for a second it shows 900 for me, and the next minute when I query the data, it shouldn't show like 1000 again, and the minute after it shouldn't show 900 again. So data what I am getting through my database should always be consistent. This should be consistent. Same time the integrity should be maintained. When the integrity is maintained, the trust builds on it. When the trust is maintained, when more people access it, and more people access it, more the market of it, and more the usage or more the application scalability comes in. So all these features are interlinked to each other. It's not that only one feature is going to exist in the system. Everything should be hand on hand. Everything should support each other. That's when the whole system will get uplift. That's when the whole system gets the right usage in the day-to-day life. And the data flexibility as well. So you should be able to handle any sort of data, be it text, be it number, be it's not going to be like a small number. It should be like handle big number. It should be handle like multiple decimals. You can whatever sort we have it, right? It should handle the data. It should have the flexibility in it. And the last and final key concept of RDBMS, as we started the concept of relation, right? the hierarchical relationship, like father and child, or uh, student and teacher, or a college or school and people in the college, be it student, be it teacher, be it different structure. There's a hierarchy in each and every structure. That's where we would discuss more into the relationship structure, like one-on-one hierarchy, or one to n, or n to one, or n to n relationship. We would go through all these concepts. So these are the building blocks of the RTPMS. I will take a minute of pause here, and anyone, if you couldn't understand any of these concept or any of this feature, please do raise your hand or use chat window, so that your question will definitely help others as well. Yes, Cedric? Yeah, you can.
Yes, but I'm a little bit. I mean, I'm a little bit confused. The point is
Yes.
that the ACID support is similar. It combines data consistency, data uh, durability, and data flexibility. I don't know why. We, I don't know
No
why.
worries. No worries. I will help you there. Okay. Now, asset support, as I mentioned, is the data integrity. Right. Now, data integrity, consistency, durability, and flexibility, it looks the same, but have a thin layer of difference between them. Right. Now, when I say data consistency, okay, let's talk about the simple example of the same ATM withdrawal. Now, today at 10 a.m., you would say, okay, my app shows, my mobile application shows I have $1,000 in my bank account. I feel good. I go to an ATM to withdraw, let's say $500 for my usage. When I go to the ATM, I put on the card, provide the enter, it has the amount, everything fine. And moment when I try to withdraw, it says, no, you don't have 1,000 in your account, you have, let's say, 400 in your account. Do you see consistency in the data of what you see in mobile application and what you see in an ATM machine?
Yeah, there- there's no
There's no consistency, right?
yeah, there's no consistency.
Whenever, yes, whenever I see the data, it should reflect the right details in whatsoever you see, right? If it
Yeah.
shows, if I have not withdrawn any amount or created any amount, whether it's 10 a.m., it should show 1,000. Whether it's 11 a.m., it should show 1,000. Unless there is an activity performed on the account. So when it reads the data from the system, the hardware or the storage, it should result you in the consistent data.
Sorry, sir. We can hear you. Hello, sir.
Hello. Hello. Hey, hi guys. I'm audible now. Just raise your hand if it's loud and clear, please. Okay, cool. Thanks a lot. Rohan. Sorry, I got disconnected. There was a power off. In a, okay, I think I was answering the question from Cedric in on the data consistency when I got disconnected. Cedric, is my response on data consistency clear to you?
Yes, for the data consistency is okay.
Yes. Okay. Now we will come on to the next thing about the data integrity or ACID properties. Right. Now, when I say integrity, right, integrity it should be like the information whatever I show to you, whether I do or do not do, it should be the right before and after, and it should be easily correlatable and to what has happened. Okay. Now, and when I say what has happened, for example, in this case, I have taken example of an ATM withdrawal where initially my balance was $1,000 and then it was when I go to ATM, I would withdraw, let's say, 100 dollars out of it. Now, the information what has been shown before start of my transaction, which is 1000, the transaction which I am performing is $100, and after transaction it should be technically $900, right? Clear on that?
Yes, sir.
Okay. Now, first any sort of issue, right? Let's say you couldn't complete the transaction. I did not get the amount. There was some network failure, or the amount is not present in the machine. Whatever be the permutations and combinations, the amount in my account should reflect what has happened at that transaction. If I got $100, my account should reflect a debit of 100. If I did not get those $100, the account should reflect the original amount before the transaction. So before transaction, after transaction should easily be correlatable to what has happened at the transaction. Hello.
Yes, sir. Yeah. We're still here.
Okay, I see a couple of other hands I see a couple of other hands which are raised. Is uh, if I pronounce correctly, it's Gidon and Priyanka.
Yes, I was just trying to say that you are not sharing your screen.
Just a second, please. Oh, my screen share. What has happened to it? One second. Is this? Just a second. It's where is this? Oops. One second. I see a blank screen when I'm trying to share. Just give me a second. Okay, I'll try to do one thing. I'll not go to the presentation mode. I'll share the screen directly so that at least you can see that. Okay. Are you able to see my screen now, right?
Yes, sir. Yes.
Okay, thank you. Sorry, when I go into presentation mode, it's showing a black screen for me. I'm not sure what has happened when the power gone off. Okay, I'll be in the normal mode, not in the presentation. So, okay. And Jed, was my answer clear to you in terms of the transaction integrity?
Yes, sir.
Okay,
It's correct
that
now.
yes, that is what called as asset support. And when I mention about data durability, all right, now today you might have, let's say, 1 GB of data and your system supports it. Now tomorrow you might have like 5 GB of data which is getting piled up, or maybe projected to 10 GB as well, or 10 times as well. Your system should be able to handle this information, right? And it's not just going to be like one day. Hardly I might extend the storage space. The system should be able to handle the additional storage what has been come up as well. Will you purchase a new database or take a license to a um, uh, new application altogether, just for each addition of like each GB of data or each terabyte of data? No, right? You want the system to handle the data growth as well. And it's not just going to be like, okay, this is the limitation. You cannot go beyond 5 GB of data, which means I will lose my business. So data should be durable for you, and data should stay on. It's not like today you have 5 GB and tomorrow morning when I come up, data is completely vanished. No one is going to use the system in that case, right?
Yes, sir.
Okay, so that is what we cover under data durability and the data flexibility. Now, when I we want to use these applications in real time, right? Now, in real time, it's not going to be one data type which is available. My name, it can be a string or a varchar. My identity or some unique number, it's of a number type. My amount in my bank account will be a decimal or a float type, considering the number of decimal points which my bank honors me or my system honors me. Differences, right? Because a trading system might go with multiple decimals of 6 decimals or 8 decimals, or banking systems might go with 2 decimals, depending on what type of decimal factor they cover in there. The system should be honoring the flexibility in the data as well. I might put down a image, I might put down a video, I might put down a string or a paragraph. I might put down 100 lines of paragraph, maybe a one complete page. I might type in and put it as one CLOP structure. It should be able to handle that. And we want to design our databases in such a way that it can handle the multiple formats of data, and it should be flexible for us. Obviously, today when a new data type comes in picture or a new format comes in picture, yes, there might be a gap, but your system should have that support where maybe the next version release or a patch release, the flexibility to add in a new data type comes in for you. That's where all these features tied up together to make a robust management system. What here we are talking about relation data, nothing but relational database management system. I hope this is clear for everyone. In case any other doubts, please do let me know.
Uh, it's, it's
Yes,
very
please.
clear, sir. Thank
Okay,
you.
cool. Thank you. Hey, Priyanka, I see your hand raised for a long time. In case you have any question, please do let us know. You can unmute
Sir,
and
hi sir.
yeah, we can hear you, Priyanka. Please go ahead.
Can you explain your hierarchical relationship again, please?
No worries, no worries. Okay, now okay. Let's take a simple example of a government database, right, which would be easily understandable. Now, from a government database, if I see, right, I would have multiple data points which a government would require, right? Starting from birth of a person. As a birth record, I would have one entry, and I would have your birth record is nothing but your unique entry into that citizenship or population of that country, right? It has its own unique record. Now, all the different record, maybe the IDs which you apply, maybe a driving license, maybe your tax identification, or your PAN card, or what you call a student ID, or you can consider, let's say, Aadhaar in, for example, for India case. All these are childs of these. Aadhaar would have different information or purpose of it. Your PAN would have different purpose of it. Your student will have a different purpose of it. Each and every entry has its own uniqueness, and they are interlinked to each other, right? Now, I cannot have an Aadhaar card without having a birth certificate, and I cannot get an entry into the school or a college without showing a birth certificate as a proof, which will give the date of birth as another additional verification point. Because these are linked to each other, right? Internally to the government database, you would have one unique entry on top of as a population entry. You would have all these details as a child of a person. And again, let's say you go to a insurance, for example, you get an subscription to an insurance. For you pay some amount, a premium amount, get the insurance. You have an insurance record, a policy record. Now, each and every visit to your hospital or a claim you claim it, right, need to be tied up to an insurance policy for which these are applicable. It can be to the same hospital, it can be in one visit, it can be multiple visits. But each and everything need to be considered to the granularity. I cannot club 223 and say it in one line. Visit 1 to hospital 1, admission 1 to hospital 2, or admission 3 into hospital 3. Everything is being claimed in one policy will be linked to one policy as a parent-child relationship. These are the relationships for you, and the same structure works in a hierarchy for you. Let's say you have your employee database, right? You might have a CEO, you might have multiple directors or VPs in the organization. Under the VP, you might have another directors or managers as well. Again, under manager, you will have an employee or individual member or a contributor. This is the hierarchy. Each and every person in this tree is an employee in the organization. But there's a hierarchy which we maintain for the business structure. Both these two will have a relation to each other, which forms as an hierarchy as a tree. In order to have as an application, as a customer portfolio or an employee portfolio, in any case, your information need to be linked together so that you will be able to access in single window. That format, that achievability of having all the information accessible in single window is what we would achieve when information is linked to each other and maintained in a structured hierarchical manner. It brings you simplicity in your business. It brings you streamlined structure of how you are going to work. I hope that is answered. Is it clear for you, Priyanka?
Yes, sir, got it. Thank
Okay,
you.
cool. Thank you. Okay, I think we are Right on the minute today. We are almost done with the RDBMS as well. Uh, okay. So what are the benefits by having all these features and all, right? One, the flexibility. So we can add it, I can delete it, I can modify it, I can expand the information, I can extend the information, whatever so required. The ACID compliance, the atomicity in my data, the transparency and integrity in my data is maintained if it is ACID compliant. And ease of use, so it should be easily accessible for anyone who wants to use it. Any non-technical person should not again go through a long understanding to say what it is. Probably any technology or any system or any application, be it a mobile phone also, be it a new app in mobile phone, it has its own learning curve. Probably that learning curve might be in few minutes, might be in few hours or a day, maybe in few weeks also. But this learning, it should be easy to make sure that instead of spending like a year long thing, you might reduce it to an hour long or a month long thing. Let's say if I want to learn database completely for myself, okay, I can do that. There's nothing wrong in it, right? But the duration I might take it probably an year long, maybe an 2 year long, depends on how much time I'm going to cater or how much realistic examples the book, the information I read through will provide. Maybe if I sit with a couple of more people, with like-minded people who are interested to learn it, probably you would share it, you would easily understand it, and information whatever understood can easily be shared, right? That brings the ease of use. It should be easily accessible to anyone. Obviously collaboration, so you have your data, the intention is multiple people accessing it in multiple locations. So the same browser what I use or the same google.com whatever I use, there are billions of people use across the world, but information is stored probably at one place or two place or three place depending on the clusters or the multiple servers or multiple data centers wherever it is stored, right? It should be collaborate. Multiple people should use it. Be it Google Sheets, you might have it, or a Gmail, you use it. And the security should be built in. So unauthorized access should never be allowed on your data. Public data have different principles and guidelines. Private data have principles and guidelines. Confidential data has principles and guidelines. So start of the session, we talked about security, right? I cannot go and open up an government portal and go through all the history of the people present in the country, right? You might have certain information accessible as a public, certain information accessible as a member of the government, and certain information applicable even if you are a member, confidential only to certain members within that government as well, right? So the security needs to be present, and we would discuss about how this is being handled with the RDPMS using the roles, grants, and everything. And normalization, we talked about like one-to-end relationship, end-to-end relationship, right? We need to design the database such that this granularity is maintained easily. As we come through the next topic of creating the tables and creating the data and all, we would understand about the database normalization. And tomorrow's session we would go deep into the next topic of introduction to SQLs, and I'll show you what are how the data is stored in RDBMS as in table structure, and then the SQL next to it. Okay, so for today we will wrap up this session at the concepts of RDBMS, features and benefits, and importance of RDBMS, why it came in, and we had a recap of what we learned yesterday with databases as well. Uh, any questions? Anyone? Feel free to use this opportunity to uh, talk through and raise your hand. I'll unmute so that you can discuss as well. Priyanka and Cedric, I see your hands are raised. Let me know. Feel free to ask in case any questions. Okay, cool. If no questions, we can wrap up the session for today, and we will meet tomorrow, the third demo session for Oracle SQL and PLSQL, and we will walk through a bit of SQL, the structure of SQL, and others as well. And thanks a lot for joining, everyone. Have a nice day. Bye.